Two flasks A and B of 500 ml each are respectively filled with oxygen and SO2 at 300 Kelvin and 1 atm. The flasks will contain, we have the pressure as 1 atm for both the flasks, the temperature as 300 Kelvin, and the volume as 500 ml. So if I apply the ideal gas equation in both of these, PV is equal to nRT and PV is equal to nRT. P is same, V is same, T is same, so N has to be same for both of them. It would mean that both oxygen and SO2 have the same number of moles. Agreed? So if they have the same number of moles, I can say that they would have the same number of molecules as well. Or to be more precise, we can say that same number of particles. And in this case, the particles are molecules. So they would definitely have the same number of molecules. What about atoms? If let's say I have X moles of oxygen and the same X moles of SO2, the number of atoms in those X moles of oxygen would be 2x, as there are 2 oxygen atoms, and the same for SO2 would be 3x, as there are 3 atoms, 1s 1 and 2 times O. So therefore 2x is not equal to 3x, and so the number of atoms won't be the same. More number of moles of molecules in flask A as compared to flask B. This statement is also not correct. Why? Because we have seen that they would have the same number of moles because of the pressure, temperature and volume being the same. So this statement is also incorrect. The same amount of gases. Now generally amount is measured in terms of mass. Okay. So let's say we had X moles of oxygen in flask A. How many grams of oxygen would that account for? 1 mole of oxygen has what? 16 into 2, that is 32 AMU weight. So X moles would have 32X as the weight. For SO2, the mass is 32 plus 2 times 18, which is 64X, right? 32X is definitely not equal to 64X. So this statement is also incorrect. So your only correct answer is option B.